we will discuss about contour machining. This contour machining is highly advanced machining process. In this machining process, we will use cavity milling for toughing, then fixed contour, then jet level profile machining, then face milling operations. In this model, we can do many ways. I am going to explain one or two ways how to do this part. You can carefully watch this video and we can do exercise as per your requirements. First, I will do modeling. Go to new models, make it folders, or already I created one folder. Then you can give it name, contour 1, okay. Now I will go for sketch command. Take rectangular command by using from center. I am going to use 100 mm length, 8 mm width. Then I am going to make another one rectangular, 80, sketch, go to extrude model, here I will extrude for 60 mm. Internal packet I am going to extrude minus 50 mm with subtract. In front view, I am going to make one profile. Go to sketch command, make it here. Take it and commands. Here 30 mm. Command 30 mm. Then I will make it take plan commands, make it 50 and on 3 30. Now we can trim it. Trim command. I will finish the sketch. Now I will extrude this arc. Then we will make some radius here. Make it fillet radius. Here we can give any one radius, means I can make it 60. Here I can make it 40. You can also see the difference if it is required, or you can trim it or you can modify it as per your requirements. Now we will go for extrude commands. If it is in infer, we make it none, then apply. Then go to trim body commands. First we go to select your body. This is your body and this is your face. Whether you want to keep up or down, I want to keep this area, so I will go for apply. Now seats are available, trim bodies are available. You can click it, you can go for hide, and here also not required right now. You can make it hide here, and this also not required. You can make it hide here. Now we are getting this type of models. Now we can make it internal fillet radius. Go to fillet commands. Yes, we can corner. We can go for 10 mm radius. See, this 10 mm radius is there. Here, this outside, we can make it 5 or 4 as per your requirement. I have made it 5. Here bottom also there. You can give both radius or different radius. This is your model. I make it 5, or if you want I can make it 8. So here we are giving different radius. In top I am giving fillet radius 5 and bottom I am giving fillet radius 8. Here in this model we are going to machine these areas. See, everything is possible. We will explain 1 or 2 models. After that model, now you can increase or decrease fillet radius or extrude depths. For example, here you can go for 8 mm or 10 mm as you like. Here you can also go for make it 4 or radius 3, and here also you can make it 4 radius. So in this way you can increase or decrease your fillet radius or depth or extrude or length width as you like it. Now we have completed this model. In this model we will do this contour. Important, this is we will machining this area. Then go to applications, manufacturing. Here came general and fill contour. Make it OK. Go to geometrical view. MCS mill and workpiece will be coming. MCS means machine coordinate system. We have to click edit, and MCS you have to put MCS. Where already we have defaulted UCS is there, user coordinate system, and you can put this MCS in the same point, or you can make it here as you like it. Okay. Automatic plane, shape clearance 10 mm. 10 mm means that the tool should come above the 10 mm from the workpiece when it will start. Second, we will go for workpiece, edit it, This is my part, and we have to specify blank. Go to bounding block. We have to put all x, y, and we will not give any extra dimensions. Make it okay. Here my workpiece material, here lot of materials are available in that library. We can click it, any material you want it. Carbon steel, the hardness is 100 to 150. I take it. This is almost equal to mild steel, so that I am putting mild steel for reference purpose. Make it okay. Now we have completed machine coordinate system and workpiece. Now we will go for create operations. Then go to cavity mill. Here NC program, we can make it program. Tool we will select it. Geometric, already we selected it workpiece. Method we will go for rough. Here cavity mill is there, or you can edit it, or you can put your name. Here which area you want to. Here part is there, blank is there. We go to specific area, cut area. Which area you want to machine this area? Means if I am putting this area, it will include all these areas also. Tool, create new tools. Go to mill. I will go for 30 mm end mill. Make it. Here defaultly coming, otherwise you have to enter it 30. The length of the tool is 75 mm. The flute length is 50 mm, and it has two flutes, and it is, you can take it anyone. I am taking it HSS end mill. You can take it HSS or carbide coated. Defaultly I am taking it high speed steel cutter. I made it reference high speed steel. My tool number is 1. The register number is also 1. In this way I have completed my tool selections. Next we will go for rough. Go to edit methods. Here roughing, I am going to give 0.5 mm allowance for finishing purposes. Hereafter we will do contour machining, jet level machining, so some materials are required for doing that operations. Made it 0.5 material, both side and floor. Here cut pattern is, lot of patterns are available. Follow path, follow periphery, profile, zigzag. I am going to use zigzag. The tool step over is after completion of one cut, how much distance it will go. We make it 40 mm. And this is the common depth constant. Every time I am going to take 0.2, 0.3, 0.5 material, I am taking 0.5 material. You can see it will take depth of cut 0.5 mm material. The total depth is 30 mm, it will take it. Go to cutting parameters. You can check it, stock 0.5 mm inside as well as floor. In staging, it is climb milling, means down milling. It is up milling, you can put it anyone. Cut angle we will decide after that. Non-cutting moves. This is very important, how to engage the cutter. Either you can engage the cutter by helical or dampen shape. If you are putting plunging, it will directly hit the workpiece. So you may have chance to vibrate and tool may be broken. Better we will go for helical or ram. Retract the same way how the engage is done, the same way retract will be done, and that after completion of the machining operation, the tool first 3 mm, then 10 mm. Now, most important part is feeds and feeds. We have to click it. Everybody is putting spindle speed approximately 2000, 3000. It is not a advisable method. Your material is workpiece material is mild steel and your tool material is HSS. So as per calculations, as per parameters, it should be 25 to 30 meter per minute. You have to enter first this here, 30 meter per minute. This is important. After that, you have to calculate feeds and feeds. The feed per tooth automatically calculated 0.393. The spindle should rotate 318 and you have to optimize feed rate. We have completed all those things. Now we will go for generate the machining process. What happened? If somebody is putting unknowingly, we have not selected any internal area, we have selected what happened? Why it is there? We will go and we will change. Here we can change. We can make it follow part. You can change it. Now we will go and see what happened in this machining process. It is following the part methods. Now, our question is that why it is not moving the material? Because in this method you have specified only this outside area. So you have not specified that. You have to put and you have to go for, or you can make it, this is my specific area, then you can see that, then go to OK. Now we have to generate that path. So here we will do some mistakes, means trial and error methods. What will happen? Normally the programmers, how they are doing and how to rectify. Now we will go and see verify. We will see what happened or what will happen if you are using this way. Follow part. We will make little bit faster. This pattern is used by the part which shape is there, the same shape it will take the material. Here see the difference. Each and every time it will cut 0.5 mm depth and it will create some steps. I will make it little bit faster. Here also you can see that each and every time it will take 0.5 mm material and it will make it some step form. For that, in this roughing process, we get given 0.5 material inside and 0.5 material in floor. Still the materials there. Here also materials there, and sides also there, and bottom also there. We will save. Second operations. What will happen if it is, we will do change instead of 0.5 to 0.2. Means you have reduced the depth of cut 0.2 mm. It will automatically take or it will increase the time, but the step is 0.2 mm gap. So it will be very helpful if you are using ball nose operations. In cavity milling, if you are giving step more, means 0.2, 0.3, 0.5, 0.8, 1 mm. By using fixed contour or contour machining, the ball nose radius will give more loads. Normally, we should not give more loads on ball nose cutters. Since ball nose cutters having cutting edges, and maximum it will take 0.2 or 0.3 or 0.4 material. So we should not give extra load that cutters. Means the cutter may be broken or may be blunt. So as much as possible, we can reduce the load to ball nose cutters. So we can make it in cavity milling, we can make it steps. Go to 0.2 or 0.3 or 0.5. Don't go for 1 mm, 2 mm. Otherwise, the ball nose cutter having lot of loads while doing machining. Another one disadvantages, or you can say that if you are reducing the depth of cut, it will increase the time. It is depend upon your this workpiece, whether the workpiece is casting or forging, or whether it is plastic mold work. If it is in high precision work, it will take some time. If it is in casting, you can go for 0.5 1 mm depth in cavity milling. We will go and check it. See, just now the step is reduced. You will see 0.2 depth. Means you will see each and every time 0.2 mm depth of step will be available. I will make it a little bit fast animation speed. Okay. Please remember that we get given allowance 0.5 mm both side and floor. Now we will go for rest milling operations, which the cavity mill 30 mm will not enter or will not or has not removed the material. The rest milling operation will do by reducing the tool size. Create operations. Go to rest milling program. we go to selected tool, workpiece is there, we will go for semi-finishing operations. Still we have not finishing, we will go for finishing by jet level. Next milling, see area, we can make it. We can rotate and see whether all parts are selected. Okay, tool, we can go for create new tools. Tool, you can select it 10, 12, 14, 16, 20. I can give for 16 mm cutter or 12 mm cutter. 12 mm cutter. Tool number is 2. The register number is 2. And the cutter is, I am also same cutter, means same type of cutter, high speed steel. Okay. Will semi finish. Here I am going to give point to material for future machining operations. The only thing is that in cutting parameters, you have to click it and you can check it here also. Point to materials there. Then containment with automatically use level base coming. Then here you have to put reference tool. If you are putting here none, the reference tool will come. First we have used that 10 mm mill, you have to indicate it. Okay. Then feeds and feeds, the same 30 meter per minute is same, but the cutter will rotate 796 rpm revolution per minute since the diameter is very less. We have done it everything, we have to generate machining. In this rest milling, as a name itself, rest milling means rest of the material previously done or left by the previous operations. The material will be done by current tool or current operations. It is simple meaning. Here you can depth of cut, we can make it 0.2 or 0.1. Make it 0.2. The tool diameter I have reduced. Here I am using follow part. Till point to material is there in all places. First cavity milling, we gave given allowance 0.5 mm for both on side. In this rest milling, again we are giving allowance for 0.2 mm both side and flow. Now we will go and see both operations. First cavity milling roughing. We will little bit faster. Then second tool, rest milling will be coming. This is the material left by dia 30 or cavity milling. Here this material is removed by the dia 12 mm end mill. Still material is there. 0.2 mm material we can given both side and floor. Still the material is there left. 0.2 mm material is there in floor as well as side. Proceed. Now we will complete this surface by using fixed contour. Fixed contour. Program is there. Tool we will select it. Workpiece is there. Here we will finish. This is my area. If you want it, you can take this area, but I am using some different operations. By using same fixed contour, by using small radius cutters, I will use, so that now I am finishing this outside area. Go to area milling. Here go to zigzag. Make it climb or conventional milling. Here make it scale up. This scale up height I am putting 0.005, the minimum gap. Here I can go for on part, that automatically I will explain after that how it will affect automatic, how much cut angle we can give it. Jet level zigzag. Here also optimize, I am going to cut it. I am going to give cutting parameters, non-cutting move same. Here we have to go and put 30 meter per minute. Here we have not selected any cutters. We have to go and select cutter, create new cutter, go to ball mill, and ball mill I am going to use 8 mm. Okay, here I have to put 8 mm. The length is 75 mm and float length is 50 mm. This is high speed steel. Ball nose. Here tool number 3 and register number 3. Generate the machining process. We will check it. We will make it slowly. The machine speed. Now we can machining by using this method. Also. First I am using this method. So if I am going to edit fixed contour, I make it here that angle, specify the angle 90 degree. What will happen? Same way it is doing. Now I am make it here 180 degree. See, this is also one of the method. Now we can go, we can edit, we can check it. We can merge the distance, we can make it 30, we can make it 30 and go to OK. And one more thing is that it is exactly, see, the cutter will come in the positions. Now we can increase 2 or 3 mm above the part. So in this case we can go to cutting parameters. Here extend its edge. So see, the figure shows that the bar, it will extend up to 55% of the tool. If you are using 8 mm tool, means almost 4.2 mm, it will away. You can check it. See, the toolpath is somewhat extended from the contour. We will generate it and we can check it. See, the tool, it starts from outside 4 mm away from distance. So it will be helpful, it will touch all surfaces. It will remove each and every corner, each and every surface of the workpiece material. After that, it will. Now we have completed. Now we have to complete this fillet radius surface here also. First we will do here. Again go to create operations, go to fixed contour, this I have to select this each and every surface. Carefully select the surface. This surface to be machined by using contour machining. Again go to area milling, go to zigzag, conventional, make it scale up. Here we can go for 002, make it plain. Already we have experienced that we can put it 180 degree or 90 degree, we can check it. First I am putting 180 degree, what will happen? Here jet level zigzag, optimized methods 0.002, and here I am going to put 20. Here also I am going to put 40. So in this way you can increase your surface finish. I will go for ball nose 5 mm, if it is available 5 mm you can take it. 5 mm cutter, this high speed steel, the tool number 4. Here also this tool number is register this 4. Then feeds and speeds, I have to click. This is 30 meter per minute. So put it 1910. Optimize feed rate. Now we will go and check it. Generate the programs. Verify that how it is going, whether improvement is required or not. Here it is taking that material in longitudinal directions. Suppose you want to do in crossways, means here only the way you have to go and put it here 90 degree. Again we have to regenerate the toolpath. Go and check it. The toolpath is direction has been changed. Okay. Now we will go for this bottom machining. You can use by same cutter or you can make it some different cutters. If it, you can create new or you can make it copy and make it paste. The only thing is that you have to change cutter ball nose or you have to take it new cutters or the old cutters. First I require ball nose 6 mm. You can make it 6 mm or you can use by 4 or 5 mm previous cutters also. 6 mm cutters I am going to use it. The tool number 5 and the register is 5. Here only thing is that, see here previous area is there, you have to go specific cut area, you have to remove this one and you can put new. This is your surface, you have to machine this area, you can click it. Okay. Feeds and speeds. Here you have to click it. That RPM should run 1592 revolution per minute, 250. Again we go to generate parts. We will go. So, using jet level machining process, create jet level profile. Program is here, tool we will select it. For pieces here, we will finish it. In this finishing, still again point to metal is there, and we will go for here semi finishing. In semi finishing, I will select that area, this area, this area. This is the area I am going to using by jet level. Okay. Here see, here I am put it 0. Here with cutting parameters, here in this top I remove that one. Inside I am not going to give any material. Inside I should finish, but again I am going to give material on point 2. I will use by face milling. This bottom surface may be important. Just I am showing you that how to do this surface separately. The mill finish is there. Minimum cut length is there. The distance 0.2 mm. Here you can consider 0.2 mm. Here still you have not selected cutters. You can go on select cutter, new cutters, or already you have selected old cutters. You can also take it, this cutter also, this ball nose mill, or you can create new. If you are having confusions, you can go to N mill, make it 10 mm, means it is having very less amount of material. You can put tool number 6, the register is 6, and your cutter is high speed steel. In this model or in this workpiece, we have removed all materials except in bottom, in floor, still 0.2 material is there. Now we will take it another operations. We will check it. Now it will completely remove side materials, and it will, we are giving allowance on 0.2 material still in floor. But actually it is doing following part. By speed only it is not visible. See, the material is removed here. Material is there. Here. Now we are giving material here. But blue color zone. This is still 0.2 materials there in bottom. Means this surface may be important, so that I am using face milling by removing these materials. See, this is the model, this is the workpiece. You can do number of ways. You can make it cavity milling with finish contour, cavity milling jet level with finish contour, or cavity milling with rest milling, or cavity milling with rest milling with pencil machining. You have to complete. The main important focus is we have to reduce the time, and the surface finish should be up to the level. Finally, we will go for finishing this face, this floor. Go to planner, make it face milling with boundaries. Program is there, tool we will select it. Workpiece is there, we have to finish. This is the final operations. We can select it 8 mm, 10 mm, 12 mm, 14 mm as you like. means I can take it for reference purpose only. Otherwise you can take it 20 also, it doesn't matter. Here I can consider 20 mm because it will take only bottom of the material only. Tool number 7, register is 7, my cutter is high speed steel. Here I can use follow part or follow peri or zigzag, make it follow part. Tool plot is there, make it 30. This blank distance very important here. 0.2 is blank distance and I am reviewing every time 0.1 material, so I don't want to keep any extra material. This I have to finish it. Feeds and feeds, I have to go for 30. Here the cutter should rotate 477. We have to optimize feed rate. We have completed everything. We have not completed face boundaries. We have to click it. We have to show this is my face. The cutter will rotate in this area and it will remove 0.2 material. So remove the material. Here the 0.2 material is removed. We can also verify it. If this white surface visible means the surface has no extra or additional material. Now we will show all operations at once. Here we go to generate path once again. Go to Toolpath, verify it. I will make it animation speed a little bit faster. You already have seen it. Second tool. The third one is finishing contour. Fourth one is finishing contour. Fifth one is also finishing contour. Next one is jet level machine, profile machining. Last one is face milling. Now we will analyze this part. Is there any material is left in this workpiece? We have to see, analyze it. So this 0.000 means almost we have completed all machining operations and all material has been removed. Okay. Our next standard process is do post processor. Go to post process, take it mill 3 axis. You are giving number of post processor available in that library. Numeric 840DIN means inch, mm means metric. Here I can take it mill 3 axis. Here where you want to keep the file, here it is very important thing. G code you want to get mm or inch. If you want mm, we go to click it metric, then make it OK. These are the outputs. You might be knowing that G40 cutter radius compensation nil or cancel or 0, G17 XY plane and tool plane is Z direction, G90 absolute coordinate system, G71 this reading will come on metric, G91 incremental coordinate system, G28 reference, T01 means tool number 1, M06 means tool change, automatic tool change. Then S318 means RPM 318, M03 means spindle clockwise, Z43 cutter height compensations with the tool offset number is H01. So we can close it, and the next operation is we go to simulate the machine. Before simulating machines, you can go for machine tool view, make it generic machine, make it edit, go to retrieve, and we are giving a number of machines available in that library. Since we are doing milling operations, we go to click it milling. Okay. Then you may go for or guidance and cinematic controls. Take it any one control which you have in your subfloor. I don't know, suppose if you are having. Okay. Then another one is how to put this workpiece in your machine table. I am putting here this is the bottom piece. I have to put on my CNC milling machine table or vice. Okay. Here workpiece source. Okay. Then go to simulate machines by using material removal rate. This is showing, just showing purpose only. Machine simulation method. I made it fast. In this way you can simulate and see the workpiece, close it, and we can remove the machine from this one. So the final step is documentation. You go to get or you go to store the documentation for future reference purpose. Here documentation, program sheet, the part name is contour, unit is mm. These are the operations we have used: cavity mill, dust milling, fixed contour 1, fixed contour Z level, and here which cutter we are using, the same cutter we will be giving the time in minutes. For example, for face milling it took 1.76 minutes. For Z level it took this much minutes, and fixed contour by making small radius 5.61 minutes. In this way you can keep this program sheet in record for future reference purpose. Now we will conclusion that we have done a cavity milling for roughing purpose, rest milling also, then fixed contour by using that surface, fixed contour by using this fillet surface, with fixed contour we are using this contour, and fixed contour we are using the bottom surface, and jerk level profile we are using jerk level profile and remove the material, and face milling we are using face milling to remove the contour material. I think that you have watched this video, so you can make or you can change as per your requirements. We will close, save all and close, and we will close this session.
Thank you for watching. Please like, share and subscribe. And if you have any doubt, kindly let me know in comment section.